The last simulation we looked at introduced the idea of Ohm's law, which is as we change the resistance, we're going to change the rate at which electrons flow through the circuit. Similarly, we can change the voltage to change the rate at which electrons flow through the circuit. Ohm's law is given by V equals IR. The V is pretty obviously going to be voltage, which is measured in the units of volts. R is resistance, which is measured in the units of ohms, which is the Greek letter omega, which is pretty much an upside down horseshoe. So this is a 10 ohm resistor. I is amps, which is usually just abbreviated with the letter A, and it's a rate of current flow. You won't need to know this part in particular, but it's how many coulombs pass a point in a given second. What we saw in our last simulation was as we increase the resistance, the current slowed down. And you can see that mathematically, increased resistance, decreased current. And we'll have an inversely proportional relationship. Another way I could increase the flow of the current was I could increase that voltage and essentially push harder to drive those electrons through. Mathematically, V equals IR is really simple to use. For example, here we could find the current in this circuit. Nine volts, already in the correct units. R is 10. Solving for I, we'll get 0.9. The units are amps. It is rare that our circuits are going to be this simple where we just have one resistor in them. But we are going to now look at more complicated circuits. And when we have multiple resistors, how do we treat them? And how we treat them is going to depend on whether they're lined up together in what we call series or whether we have branching in the wires and the resistors are in what we call parallel.